Welcome, everyone. This is the SOLIDWORKS User Group meetup, and we're super excited to have everyone here and to talk about sheet metal bending with James Letson. But before we start, I want to talk about a few things and give a few community announcements. So, first and foremost, if you haven't been involved in the community before, the SOLIDWORKS User Group Network is a community created by users for users to level up and share techniques and presentations around everything around SOLIDWORKS and 3D experience. And the SOLIDWORKS User Group of New York City is the representation of that, but specifically servicing New York. We host events that are online and on-site. We tend to do them hybrid if we can, and if not, we'll have kind of like today, in which we only have an online presentation, which of course we're not limited by boundaries. So that's what we're doing today. So as we start off, as I mentioned, I have a few community announcements that I need to share with everyone here, and then we'll kick off with the presentation. And first and foremost, the SOLIDWORKS User Group Network is moving to Bevy. This is something that has been evolving for the past few months, but the whole SOLIDWORKS User Group Network is moving out to Bevy. So this is going to be very interesting because, it means all of the meetups or meetup groups that you might have been involved with within Meetup, they're going to all be shifting to a new platform. Bevy is a landing page that is used by, it's a community platform that is used by Salesforce and Google Dev Group, and it gives a lot of functionality to be customize it to what the direction of the meetup or the SOLIDWORKS User Group needs to be. So this is going to be very interesting, and it's rolling out worldwide, and it's going to have a whole bunch of interesting functionalities for users and both users in general, whether you are a SOLIDWORKS User Group leader or a participant. So that's coming up. But of course, because of that, the announcement for this group is that this is the last event that we're hosting or communicating through Meetup. This is going to be, this is the last one. So after this, we're going to shut that account, and you can expect within the next 4 to 6 weeks, the landing pages are going to be created, and we're going to roll those out, and the migration is going to start, is scheduled to end in February 2025. So by February 2025, you can start joining into your regular meetups. I've rolled out questionnaire to capture all of the people's emails that they want. If you want to continue with the work in the meetup group, you can. So if they want, I can share that to the participants in this group, so that if you're interested in participating with the New York group, you can, and you're just rolled up as everyone else as soon as the groups comes in. So, and of course, the second event is a lot of people here already know, is the 3D Experience World of 2025. It's going to be so much fun. It's going to be held in Houston, Texas, and that's going to be super exciting. It's in February 23 to February 26, so it's really around the corner. So that's going to be super interesting. I've gone there twice, and it's been a wonderful experience for me, and I know I'm sure a lot of people here online would share the same thing if they were talking with someone new. So highly recommend to go. It's 3 days of pure fun, connection, and learning, which is along with a community that is very interested and engaged. So this is a wonderful experience, and I highly recommend people to go. So kicking off to our main presentation with James Letson. So I'm handing off the presentation to him. So you can take over, James.
Sounds good. Let me get my screen shared here. Okay. Looks like it's good on my side. Can you see that, Stephanie?
Yep, I can see it. We're good.
Awesome.
Can everyone see it? I think everyone should be able to see it.
Yeah, I
I'm
can
seeing
see it.
Perfect. So we're good to go.
Open this chat up so I can keep an eye on it as well. Cool. Well, good afternoon, evening, morning for some of you. My name is James Letson. I am a designer with Altec Industries. I've been here almost 5 years. Here in about 2 weeks, it'll be 5 years. I am a SOLIDWORKS champion. I run a user group just like Stephanie does. Mine's a little different in the sense that it is a Altec like internal group, so it's not region based like Stephanie's is. I am currently a SolidWorks, a certified SolidWorks professional. I do have my CSWPA, the advanced course in sheet metal, working towards my CSWE. Hopefully by the time I present this in World here in less than a month, I will actually have that expert certification. That's all to say, I at least kind of know what I'm talking about, right? And then a little bit of personal stuff, some hobbies. I am a motorcycle enthusiast, coffee connoisseur, and a amateur photographer. My wife likes to joke that my real hobby is hobby collecting, because I tend to do a lot of things and put down things and pick new things up pretty regularly. But with that said, there is a QR code on the screen. If you scan that with your phone, it will be it's like a virtual business card. It should be an email there. If you ever have any sheet metal questions, feel free to send me an email. Hopefully I'll be able to help you, or I can at least point you in the right direction. With that said, we are going to get into my presentation, Beyond the Bend, Advanced Sheet Metal, SolidWorks Sheet Metal Techniques. The idea here is I want to touch on some sheet metal techniques that I feel like are lesser known, and maybe either you've never been taught them, or you've tried using them and maybe you weren't able to get it done, or weren't able to get it to work like you wanted, or maybe you've never heard of them. But the topics we're going to talk about, we're going to start by talking about the sheet metal trinity, mastering the three core sheet metal techniques. We'll then move on and we'll talking about flattening the curve, unlocking the secrets to flat patterns. Third, we will talk about geometry gone rogue, some tips for taming imported parts for seamless design. And then finally, we will think outside the fold. We'll talk about some creative solutions using sheet metal features for things that you wouldn't typically think you could use sheet metal features for. So to get started, first topic, sheet metal trinity. So the first thing I want to talk about is a feature in the sheet metal suite called insert bend. Insert bend is really the OG sheet metal feature. Talking the first thing that was released in 97. So this is what 3 or 4 years after SolidWorks was actually released. This was the first sheet metal feature that was added to the software. Up until SolidWorks 2001, it was the way that users created sheet metal parts in SolidWorks. The cool thing about insert bend is it can be used on cylindrical and conical shapes. It's really powerful for dealing with imported geometry, and we'll look at that when we get to our geometry gone rogue section later on in the presentation. And then a few things here is you do typically need uniform wall thickness, and the tool doesn't really like if the corners of your part are already radiused, right? So basically the gist of how it works is you start from a thin feature solid body. You choose a fixed face and edges to rip, and then you end with a sheet metal part that can be flattened. So I'm actually going to hop into SolidWorks here and just kind of give a quick how-to and a quick tutorial live demo here of how insert bin works. So in this example, like I said, I started with a solid model and I just shelled it. So it's basically just a thin feature made to look like sheet metal, right? And what we're going to do is we're going to come up to our sheet metal tab. And if you don't have sheet metal tab, if you right click up here anywhere, come to tabs, you can turn that sheet metal tab on. But we're going to come all the way to the end. It's like, the very first sheet metal thing that they ever put in here. And then they just kept scooting it all the way to the end, right? As they added more. But we're going to click insert bin. And the first thing it's going to ask us for is it's going to ask us for a fixed face. So this is just what makes sense in when you're creating the part for what face to be stationary, right? So we're just going to choose this bottom face here as the fixed face. And then what we need to do, because the way that this individual part was created, you can look at it and you can tell, okay, this corner, I didn't actually want to click that, these corners here are going to be bins, but some of these corners are not, right? So what we need to do is we need to tell SolidWorks which corners we want to be ripped. So which corners are not going to have a bend radius on it, right? So we're going to click, basically it's going to be these 3 on each side here. I'm going to say 1, 2, 3, 4, 5, 6. And then when we hit our green check mark, we're going to get a little pop-up that just like, hey, we added some auto cuts, auto reliefs. You can just hit okay. And now you can see that we have a sheet metal part that is flattenable, right? The cool thing about this is another little feature in here. Let's just Control Z a couple times and then go do this one more time. Choose my fixed face, choose my ripped edges. And you'll notice as I click these edges here, you'll notice the little yellow arrows that come up. So when I made this sheet metal part with insert bin the first time, the like side flanges here and this back flange were just like butted up against each other, right? But let's say I want this back flange to overlap my side flanges. So that's what these little arrows are. So basically what we're going to do is we're going to say we want to rip in this direction. So the material that the arrow is pointing at is going to be cut back, right? And so we'll go through and we'll click all 6 of these because we want, maybe we want that back flange to be overlapping the entire part. So now when we hit our green check mark, we'll get the same pop up and you can see now that back flange overlaps the entire, overlaps the entire of all of the side flanges. So that is a quick and dirty of how to do insert bend. Like I said, we'll touch a little bit more on it on some cool Stephanie, are you seeing my screen?
Yep, I am.
Okay. I just got a direct message from someone who asked if I was sharing my screen. So I was just double checking that you could see it.
Oh
Everybody else
yeah.
can see it too. Will, can you see it out there?
Yeah, I can see it.
Okay. Yeah. So
So
I
you,
apologize. I'm not gonna try to say your name. But I am sharing my screen, so maybe maybe
it's probably
leave the call and join again. Maybe it'll work.
yeah, it's probably if you're joining from your phone, you probably need to like shift to another screen in order
Yeah.
to see the screen and
Cool.
itself.
Okay. Well, I'm gonna keep going then. I just wanted to double check. And I see another question here. What if we use convert to sheet metal? We will get to that soon. That will be one of our sheet metal Trinity features, indeed. So yeah, that is insert bin. We're gonna move back over here to my presentation. So the next thing I want to talk about is what I like to call base flange and franz. Base flange tab is the like de facto standard sheet metal feature, right? Anyone that has any time using sheet metal in SolidWorks, this is most likely what you use. This is the go-to. This is, you know, since 2001, this has been the standard sheet metal feature that everyone is taught and everyone is most likely using. But there are a few things within this, oh, excuse me, within the base flange and franz category that I want to talk about. Edge flange, there's a few different tools within the edge flange feature that I want to touch on. I'll touch on mitered flange, and then I'll touch on jog, just because those I feel like are some lesser known base flange and franz tools, right? But the way that base flange and franz works is you're going to start from a thin feature sketch. In this one, you'll notice that I'm not creating a solid model. I'm just starting from a sketch. I'm going to declare material thickness, bin radius, K factor, all of that good stuff. You do get a preview, and then you end with a sheet metal part that, again, the whole point can be flattened. So let's hop back into SolidWorks here. Let me show a few things about base flange and franz. So here's a pretty simple, whoops, get that back up one more time. There we go. Okay, so here's a pretty simple part that was created using base flange, and then I added a little edge flange over here. So the first thing I want to talk about is some of the things within edge flange. So I'm going to come up to sheet metal, and I'm going to go ahead and just click edge flange, and I'm going to pull a new edge flange out like this. So the first thing I want to talk about is flange position. And it is located down here at the bottom of the edge flange feature manager here. And as I click through these, you can kind of watch what it's doing, right? You can, this one that I have it set on is bend outside. I can go just material outside, or I can go all the material inside. And really that's just looking at, it's taking what was already there, and it's, trying to decide if you want to add extra material before you add that edge flange or not. Also in this feature manager here, there is this button up here that is edit flange profile. This is a really cool tool within the edge flange feature that, we can create this edge flange like this, but what if I wanted, what if I didn't want it to be this full width? I didn't want this entire 5 and almost 3/4 of a width. Maybe I just wanted it to be 2 inches centered on this flange. Now that you have this created, you could start a sketch on this face and cut it, but there's an easier way to do that. If we come back up here to our edge flange feature and we edit, we can click our edge. And if I would have had multiple flanges or multiple edges chosen, there would be more here. So you would have to specify exactly which one you wanted. But since this is the only one, I'll click it, and then I'll click edit flange profile. So now what this has done, this has put me in a edit sketch mode. And I'll go normal 2 here so we can see it a little better. And what this allows me to do now is it allows me I can break these like soft relations that this has. You'll see like this corner down here is black. It looks like it's fully defined. But when I click and drag, you can see that it turns blue, and it allows me to move it. So like I said earlier, maybe I just want this to be 2 inches. Let's throw a dimension there, and let's center it on this origin here. So we'll throw a construction line there and make it vertical. it didn't attach itself to the origin. There it goes. And then when we hit finish, we'll see that we are left with a edge flange that is not the full width. We were able to, in one feature, add an edge flange and change the width of it and the location of it. And then the last thing I want to talk about in edge flange, we will come back up here and edit feature one more time, is this down here below flange position. There is a little checkbox here that is offset. And basically it's, if we were wanting this to, say we were wanting this flange to be a mounting flange, but we needed it, we needed the whole thing to be, maybe we needed an inch more to this like vertical here before the flange started. You could come in and you could add a tab to that, extrude a tab to it, and then add your edge flange after. But the other option is you could come here and you can click this little offset button here, and you can kind of see what it did automatically, right? And we can change, say we want that to be 1 inch offset, and then hit our green check mark, and now we have that flange still in one feature, offset however much we may have needed it to be. If you had, maybe we had a flange on this side here. Let's see, let's go back to edge flange and click it one more time. Maybe this edge flange was longer, and maybe we wanted this edge flange to be coincident with that one. We could come up here and we could edit that one more time. Well, because I have it, let's move that one back. There we go. Now we can edit, and I can, instead of saying blind, I can say up to vertex, click this vertex here, right mouse button completes, and now we offset it still with only one edge flange feature. So that's pretty cool. Okay, so next I want to talk about, still in base flange and friends, I want to talk about a miter flange real quick. So let's go ahead and delete that. No, I didn't quite mean to delete the other edge flange. Hold up, let's move it one more time. We'll just go back to blonde and 1 inch. I'm gonna use that later on, so we'll keep it there, and then we'll delete that other edge flange. Okay, so miter flange. It is also located up here on the sheet metal tab, right below edge flange. And a tip I want to give, the first tip I want to give is, before I show how it works, is when you click miter flange, if you then just automatically click the edge that you want your miter flange to start on, you click it, and just like if you were to click anything else, it's going to go right into your sketch, your edit sketch mode, right? But the cool thing, and once I exit this, you'll see it, the cool thing that it does is it creates a new plane right at that vertex for your sketch to go on. But then the way miter flange works, we're just going to grab a line, and let's say we want the profile to look like that. And basically what this is doing is it's basically a sheet metal sweep feature, right? So when I exit this sketch, it's going to automatically go into the miter flange. And then what I can do is I can click adjacent edges. And like I said, it basically just sweeps that sketch that I did, a thin feature sketch across the tangency on those adjacent edges that I chose. And then the cool thing about miter flange is it handles all of your corners, all of your cuts and everything automatically. You're not having to worry about, like, throwing multiple edge flanges in there and cutting them and hoping they look right. So yeah, that is miter flange. The last thing I want to talk about in the base flange and friends is going to be jog. Jog is one that I feel like doesn't get used super often, and it's maybe it's just not something that's taught, or but even when it is used, I feel like there is a key feature in it that people overlook, and I wanted to kind of point that out. So the way jog works, I click jog and then I click the face and it just automatically takes me into a sketch. And basically, I'm just going to draw a line kind of wherever I want this jog to be, right? I'm going to exit sketch and it's going to take me right into my jog feature. Now I am still in miter flange. That's funny. Okay. Exit sketch. Delete the miter flange. I think I clicked the wrong one. There we go. Let's do it again. Okay, so we're in jog now. Let's draw us a line and exit sketch. Okay, so it's going to take us right into our jog feature. But just like the way insert bend worked earlier, it's going to ask us for a fixed face. So it's really just what side of the line, left side or right side of the line, do you want to be stationary? So it makes sense for this to be our fixed face, and then you can see that it automatically starts projecting this jog. So the one thing that I wanted to point out within the feature manager of jog is this fixed projected length checkbox here. It's pretty cool, pretty powerful tool that SOLIDWORKS has. It basically what it's saying is the length of this flange before you applied the jog. When you have it checked, it keeps that length. So, you know, from this face here to the measurement from that face to this face stays the same when it projects this jog up. And you can see if I uncheck it, you can see that it shortens it. And basically what that is like, oh, if you designed this knowing what you needed your flat length to be, you would uncheck that because you knew, okay, I wanted it to be, you know, 6 inches flat and then apply the jog. And I can, you know, check it back and you can see basically it's just adding material here. It's just a cool feature. I feel like gets overlooked there. So that is base flange and friends. Any questions there? I didn't say this in the beginning. If y'all have questions, put them in the chat. Me or Stephanie will see them. Or if you want to come off mute and ask your questions, feel free to do that as well. I'll definitely answer any questions at the end, but I would rather you ask the question now and me get the answer before I move on. But I'm not seeing anything in the chat and I'm not hearing anything, so we will move on to the next thing. Okay, so the next thing, and this somebody in the chat was actually asking about this one earlier. The last of the sheet metal trinity is convert to sheet metal. Convert to sheet metal allows you to convert solid bodies into sheet metal parts, kind of like what we did with insert bend. But you can do it from a solid, not from that like thin feature solid that I had on the other one. Oh wow, I got a typo there. I'll have to fix that later. And then once you convert it into a sheet metal feature, you know, your base flange and friends can all be added to it. The cool thing about convert to sheet metal, the useful thing about it, it is super powerful for complex angles, and you can use it very easily for multi-body sheet metal parts, which is kind of, excuse me, what this example is I have here. And then for later on, it's good to know that it does not need uniform wall thickness like insert bend does. So the way it works, you start from a solid body, you choose a fixed face and the edges you want to be bent, and then you end with a sheet metal part that can be flattened. Again, just like the last two things that we looked at. So I do want to show this one as well. Let me find my part. Here it is right here. Okay, so same kind of part that we had earlier, right? Except it's not a thin feature part. And we're going to come up here to convert to sheet metal. And what it's going to ask us is it's going to ask us to choose a fixed face, just like everything else has, right? Choose a fixed face, and you can actually see that it's projecting. You can see the projection or the view, the preview that it's showing us there. And we can actually come up here and we can say reverse thickness. So now it's on the outside of that original part. And then another cool tool here within the feature manager is the keep body, and we'll show it here in just a second. But basically, when you're wanting to do a multi-body sheet metal part, that's what you would use. But next, all we're going to do is it's going to ask us for bend edges. So whatever edges we want to be bent. And you do kind of want to watch order of operations when you start clicking these edges. If I know that I want this side here to, be 3 different bends, I don't want to come up here and click this one first. I want to click them kind of in order, and you can see it adds a preview as I click it. And then, we can click all 6 of them. And then when you hit the green check mark, you now have a sheet metal part that, I could come in here and I could add an edge flange to, because it is now a sheet metal part just like any other. So we'll go back into this convert to solid thing here, and we'll check this little keep body box this time. And I'll show you what it does. When you hit the green check mark, you can see that now both of the bodies exist, right? We have our sheet metal part, but we still have our boss extrude. And this comes in handy when we have super complex things like this part. And this particular one, the way that my company works is we do stuff in assemblies. We don't do a lot of multi-body parts, so it's ultimately made into an assembly. But if I click and open one of these parts here, you can see that it was done the same way. I can come up here and as I just roll this bar back here, you can see that the person that designed this started with a solid feature, and they just kind of cut it away a bit, right? And got the shape. And you can look at this, like you can tell this is a complex feature, a complex part. Thinking about having to do edge flanges on this, it gives me anxiety just thinking about it. So that is where convert to sheet metal really shines, right? Is it allows you to try to find where it actually, oh, there it is right there. So that was kind of what it looked like before, and he converted one panel, and we can come in here and click that keep body, and we can see it does the same thing that I just did. So that was the way the person that designed this did it, right? He did this, he kept body, and then he went up here and he converted to sheet metal again and chose the next one. And maybe we just want it to be that flat piece. And now you can see that that piece there is its own body as well, or its own sheet metal part as well. So that's a quick overview of convert to sheet metal. We will move on here. We are yes, the face does become a body, or it's a sheet metal part, right? So if let's go back one more time real quick. Thanks for the question here. So if I come and I actually just hide that solid body, that was not the right one. That is we'll go back to this one. Okay. I go hide this solid body here. You can see that now I have two. So this is what I was calling a multi-body sheet metal part, right? So we have one body and we have two bodies.
So question
then,
here is,
what's up?
sorry, I have a question too.
Yep.
So when you say that you guys work in assemblies, you mean in this, like within a part, you create the full body assembly with multiple parts, like this part?
Yeah, so the way that assembly was done, this one here is and let me unhide that. He did it in a multi-body part like this, and what he did was he got to where he got one part done, and then he just saved it as its own part and then started again to make the second part. Because we don't use the way that our PLM system works, our file management system, we can't do in context references. So the way that we have to work around that in instances where we're making multiple parts off the same body like this, we would just save each individual part as its own part number, right?
Got it. Thanks.
Yep. Cool. Okay. So we will move on here. Okay. So we move on to our next topic. Flatten the curve, unlocking the secrets to flat patterns. So the first thing I want to talk about in this section is what I've come to know as the sheet metal sandwich. I can't exactly take credit for this funny name. I have a colleague who has a YouTube channel, Too Tall Toby, that actually, at least he was the first one I saw coin this name, but it was good enough that I had to include it. But before I get into the exact details of what I mean by sheet metal sandwich, I do want to talk about exactly what this button does in SOLIDWORKS. The flatten button that's up on the sheet metal tab, it in simple terms, it's just a toggle button for suppressing and unsuppressing your flat pattern feature. It doesn't create you a flat pattern configuration. And the big thing to know to save you some headache in the long run is try not to work in that flattened state. So basically what I mean by sheet metal sandwich, and we'll hop into SOLIDWORKS here in just a second so to actually show it to you in action, but all of your sheet metal features should fall between your sheet metal and your flat pattern feature in your model tree. Those are your two pieces of bread. All of your edge flanges, all of your mitered flanges, any cuts, it should all fall between those two features, right? Oh, I went too far. Okay. And we will get back to where we were. Well, I went too far again. Cool. Oh, I see what I did. Okay, there we go. So let's hop back into SOLIDWORKS real quick, and we will hop to we'll bring this part back up. Okay, so you can see let me have one. Okay. So you can see right now, and like I said, the flatten button up here, it just toggles, is a toggle button for unsuppressed. And you can actually see it doing it over here, right? When I click it, it unsuppresses the flat pattern. And then when I unclick it, it suppresses it back. And also I want to point out that you see that everything that I've done has been done in what I was calling a sheet metal sandwich. So, I have my sheet metal feature as my top piece of bread and my flat pattern feature as my bottom piece of bread. So let's say we want a circular cutout that sits over this bend. If we were to do it from this face and we were to draw a circle here, give it a 3 diameter, and we cut this, we can see that it doesn't keep its profile, right? On the top, because this is in a formed state, the top is now squared off. So what is typically done is you need it to be flat to be able to cut that. And I've seen people do it a lot, and then it ends up causing them headache in the future. Well, they'll hit that flatten button up there. They'll then come into a sketch, draw their circle, and cut it. Okay, so now you have that circle that now it follows the profile on both of these faces, right? But when you come back up here to flatten, you can see that it now suppresses. And you can also see that we've broken our sheet metal sandwich rule. That cut feature is now outside of our pieces of bread. We don't want that tomato underneath the bread. We want it up here in the sandwich. So what we can do, there is another tool in the sheet metal suite that's right up here above the flatten tool, the unfold button. And the cool thing about the unfold and the fold button is it's going to exist inside of our sandwich, right? So we can hit unfold, just like everything else, it's going to ask for a fixed face. So we're going to click the face that we want to be fixed, and then we're going to click whatever bins we want to unfold. So in this case, I'm just going to click this bin because that's where my cutout's going to go. Hit the green check mark, and you can see that it unfolds it. Well, now I can come in and I can sketch, draw my circle, cut, extrude, finish, and you can see that this cut is now inside my sandwich. And then all you have to do now is come back up to fold. It automatically chose the same fixed face you had before. And what I like to do is I'll just click the collect all bins. I could come up here and click this bin as well. And then when I hit the green check mark, it folds it back, and you can see that my cutout now is the right profile that I wanted. And my fold is, or all of my features are in my sheet metal sandwich. Okay, so we will shut SOLIDWORKS down for a second and keep going. Next thing in flatten the curve is, I mentioned flat pattern configuration earlier. That flatten button does not create a configuration for you. Flat pattern configurations are very useful tools on shop floor prints. My company uses them as a way to show our fab department what the flat profile looks like. That way, if the part is asymmetrical or something, they can use the flat pattern on the print to help orient it before they bend that part. But the key thing you want to know here is do not make the flat pattern configuration yourself. You always want to let SOLIDWORKS make it for you. And how you do that is just by creating a drawing. You go new, you go make drawing, and even if that's the only thing you did, it creates that flat pattern for you. And then a few things about that is when you do it this way, you'll notice that the flat pattern configuration is derived. So you can see, can you see my cursor, Steph?
I can.
Okay, cool. And I can probably actually, anyway, yeah, so this second screenshot here, you can see that the new configuration that is created is derived. So it's like a parent-child relation there. And then you also notice that it does have a unique naming convention. It automatically names it default SM-flat-pattern. And that is very important because if you don't have those two things, you lose some functionality on your print. So we will hop back into SOLIDWORKS one more time just to show what I'm talking about. So we come over to configuration. We can see that I do not have a flat pattern configuration right now. I can come up here to new and I can say make drawing, choose my template, hit OK. And from this point, like I said, if I were to just close this print right now and not do anything else to it, close it, don't save it, I would now have a flat pattern configuration in my model. And you can see that, like I said before, it is derived and it has the unique naming convention. So the cool thing about that, and let me show you, let me just come up here and say add configuration. I'm going to do it the way that I tell you not to do it, just to prove to you that you lose some functionality when you do it this way. So now that one's active, we will make it so it is flat in that state. So that's the same thing, right? All I did there was I unsuppressed the flat pattern feature so that when I make that configuration active, it is flattened just like it is in the one that SOLIDWORKS created for me. So now coming back over here to the drawing, and I drag a flat pattern over here. And you can see that when I click this, the configuration that I am using is the one that I let SOLIDWORKS create for me, default SM flat pattern. And what it gives me is it gives me my bin line and bin note functionality. So you can see that all of my bin lines are on here. And you can also see that if I click bin notes, I toggle it on, it also puts bin notes on here. And but if I come up here to flat pattern, the other configuration, let's see. Oh, let's start over. Let's delete it, pull another one over, and change this one to flat pattern. You can see now that this functionality is still here, but I can't do anything with it. Yeah, obviously you can't hear me clicking, but I'm clicking this bin line thing here and or bin notes and nothing's showing up. So that's a real key thing there is you want to make sure that you let SOLIDWORKS create it for you, because then you don't have to remember, okay, it needs to be derived. You don't have to remember exactly what that naming convention is. You just click a couple buttons, make a drawing, and it automatically creates it for you. Let's see. So next I want to talk about, okay, editing flat patterns. So there's 3 things here that I want to talk about before we move on from flat patterns. The first is fixed face, which is used for when your flat pattern is not, or it's unfolding in a weird way. And you can kind of see the images here, but I'll show you in SOLIDWORKS what I mean. The second one is merge faces. It's a kind of hidden, real small checkbox tool that makes it easier for when you're wanting to export your DXF or DWG. Maybe you're sending that part to be cut on a laser or on a plasma or something. And then the last thing I want to talk about is corner treatment for when your corners look different in the formed view versus the flat view. So let's hop back into SOLIDWORKS one more time. Back up here. Okay, so let's go ahead and let's close that print because I don't need it anymore. Don't save. And we will delete that configuration that we don't want. Okay, so the first thing was fixed face. So really what this is you want to think about, and sometimes maybe you open a part that you didn't create that you're referencing or you're having to make changes to, or maybe you created the part, because I've seen it where you create a new part and it'll do this. But when you hit the flatten button, looking at this part, it makes sense that this is your fixed face, right? This is the face that's staying stationary and everything unfolds around it. Like so. But there are times when you'll create a part or you open a part where it doesn't do it. And I'll show you where it's located. If you right click your flat pattern feature and come up to edit feature, this fixed face here, if I were to clear that out and just choose another face, you can see that it didn't look like anything changed. But now when I hit flat pattern, it unfolds in kind of a weird way, right? In a way that you wouldn't expect it to. And that's kind of what I meant is I've seen plenty of people create new parts, especially if you create a part that's got like non-90-degree angles. You'll see it sometimes where it doesn't choose the face that you think it would as the fixed face. So just remember, right click flat pattern, edit feature. You can clear selections and then re-choose the face that you want. And then you can save yourself some headache trying to figure out why it's unfolding in a weird way. Okay, so merge faces was the next one. So you'll notice when I hit this flatten button, you'll notice that all of my like tangency lines for all my bins are showing up, right? So like I can actually click, all these are separate faces. So if I were to try to export this to a DXF, there is a potential that, maybe I only exported this highlighted face. And obviously that's not what I want. So we can come right back into our edit feature on our flat pattern feature. And we can hit this little merge faces button. And what that's going to do is it now makes it to where it hides all of those tangency lines, all of those tangency bend lines, and it makes it when I click it that this is one solid face now. It just makes it, saves you headache in the long run where you send some parts to an external supplier to be cut on a laser and you get them back and realize you only got the center face of your part, right? And then the last thing I want to talk about is corner treatment. So again, in our flat pattern feature, and this is something that I've gotten questions about before, where someone will create all of these, I got all these edge flanges and miter flanges created, and my corners look like, like I would expect them to, the way I want them to. But when you go into the flat pattern, they look different, and I'll show you what I mean. So you look at this corner here, but now when I flatten it, you can see that corner treatment that should look like a little like three sides of a square no longer looks like that. And you probably saw what I did there, but if you right click in your flat pattern again, edit feature, and just come and uncheck this corner treatment box here. Now, when you go into your flat pattern, it adds that corner treatment into the flat pattern. So I think that the corner treatment button is really just it's for those companies that have very specific corner treatments that they want. Like they like to add an extra amount of clearance for their press brakes or something like that. So that would be kind of where you would check that corner treatment box, right? You don't want it to apply this, you want to apply your corner treatment yourself. Okay, so that is flatten the curve, all about editing flat patterns. We'll move on to our next topic, which is geometry gone rogue. We are running a little bit short on time. This is taking a little longer than I thought, so that just lets me know that I need to speed up for my world presentation. But as long as y'all are here, I'm going to keep going. Next topic I want to talk about is geometry gone rogue. All about taming importing parts. And this would be touching on what I was talking about earlier with insert, bend, and convert to sheet metal, where those two things can be used for imported geometry. So the first thing I want to talk about in this is 3D interconnect. This is a really powerful tool that SOLIDWORKS has added that really basically sum up this big blurb of text here. It allows you to use external CAD files in SOLIDWORKS while keeping things connected and up to date. But the thing about 3D interconnect, that if your job at, all that you're supposed to be doing at your job is taking imported geometry and converting it to sheet metal parts, 3D interconnect is going to mess you up. So you want to make sure that you turn it off if that is your plan. You're trying to convert imported parts to sheet metal parts. And then how you do that here, if you come up to your settings up here, you come down to import and your little enable 3D interconnect button. You just want to uncheck that, and it will turn it off, and then you can start converting imported parts. So the first thing I'm going to talk about, there's two main questions you want to ask yourself before converting geometry or imported geometry to sheet metal parts. The first one is, does it have uniform wall thickness? And then the second one is, does the part have existing bends? So looking at those, if you have uniform wall thickness, like this little screenshot I have here, we're going to use insert bend. If you have non-uniform wall thickness, the tool here to use is convert to sheet metal. And then if you already have radiuses, I'm going to show you, this is technically a surfacing tool, but it can come in really handy when doing converting imported geometry to sheet metal parts, and that is the delete face command, and then we'll use insert bin like we did on other parts that are uniform wall thickness. So let's hop back into SolidWorks one more time. Let's see. Okay. So I'm going to come up here and I'm going to open imported part. Yep. Okay. So I'm going to say no, don't run diagnosis, just because I am converting this thing myself. So you can see that this is the imported part. This is actually an IGES file or IGES file. So just like we did on our insert bin earlier in the presentation, we're going to do the same thing. We're going to say insert bin. We're going to choose a fixed face. And because this one doesn't have any weird edges, weird flanges that would need ripped, that's literally all we have to do. It's going to look at it's going to automatically detect where it needs to put bins based on where bins already are. And then you can come in here and set a bend allowance and stuff like that. And when I hit the green check mark, you can see that it is automatically going to create that for me. And then, you know, we can change bend radius and stuff like that based off of our normal sheet metal feature, like we would on any other normal sheet metal part. So now, what if we don't have uniform wall thickness? So let's open one more part. This is another IGES file, right? And you can see pretty obvious that this part is not uniform wall thickness. So if I come up here and I try to insert bend on this one, I do the same thing. I click my fixed face. You're going to see that it only chooses it only adds bends in for the things that had uniform wall thickness. The part of it that didn't, it just completely omits it. And you can even see that it puts it turns your model tree yellow of like, hey, this is a warning, something's not right here. So let's undo that real quick, and we will show you that we can use convert to sheet metal. So just like we did earlier, we're going to do the same thing. We're going to choose as a fixed face, but this one we are going to have to choose bend edges. So as we choose these bend edges, you can see that it's giving us a preview. And when I get over here to this non-uniform side, you can see that it adds it in, and you can actually see where I have the material thickness set up here. That's something that you can change. Maybe I wanted that to be 1/4 inch instead. And you can see, well, okay, now it matches that one, but it's bigger than the rest of it. So that's the cool thing about convert to sheet metal, is that it doesn't need uniform wall thickness when you're working with imported parts. I had keep body turned on, turn that off. Okay. And now you can see I have a sheet metal part that is all uniform, and I've added my bend radiuses in there. And again, just for sake of showing you, it is flattenable. So now what if we get a imported part that already has radiuses on it? We got this from an outside company that we're working with. They modeled this part, and they put radiuses on it already, and you can see them both on inside and outside. If I come up here to insert bend, you can see that when I click it, oh wow, it did. Oh, I know. Okay, sorry. I was confused for a second. So you can see that I have set in my let's see. Sorry, let me find it again. Undo that. Undo. Okay. Insert band one more time. Okay. So when we set bend radius, that's what it was. I set my bend radius to let's set it to quarter or eighth inch, right? And I click this. The reason that it doesn't, we can't use insert bend is it doesn't, it looks at what our bend radius already was on the solid part. And you can see when I click this bend down here on the bottom right, our radius is not an eighth of an inch. Like I said, it's actually a 16th of an inch. Now, if I come in here and I add another edge flange, now anything new I add, that bend radius is an eighth of an inch. So that's the problem with using insert bend with imported geometry that already has a bend radius, is it acknowledges what the bend already was and it keeps that. So it's not going to override it. So what we can do instead, let's undo a couple times. Okay, and what we will do is, and I'm just going to show it easy, search up here. We're going to type in the word delete, and we're going to say delete face. So we click it, and it's just going to ask us, okay, what faces do we want to delete? And we're going to focus on this delete and patch option here. And we'll say, okay, let's go ahead and delete this bend radius. And basically what this is doing is saying, okay, this face here we want to remove. And because we have delete and patch chosen, it's going to extend this vertical face and it's going to extend this horizontal face. So let's go ahead and click the other three radiuses as well. And you do have to do these separate inside and outside. So like I can't do the inside radius with it as well, but let's do it one more time. Delete face. And we will click it like this. Click all four of our radiuses. And now you can see that it has removed that face and just made these sharp corners. So now we can come in here and we can run our insert bend like we would do before with our eighth inch bend radius. And we can see that it now has applied our eighth inch bend radius. Okay, so okay, yeah, I appreciate was that Ludwig there for joining. You have a good evening. Sorry, I just happened to look at chat and notice some messages there. So we will move on. The last thing I want to talk about is thinking outside the fold, creative solutions using sheet metal features for things that you wouldn't typically think that you could use a sheet metal feature for. So really, sheet metal features can be used for any kind of raw material that comes in sheets. So you think of sheet metal of like, you have like a 4x8 sheet of sheet metal. Well, what else comes in 4x8 sheets? Plywood, HDPE, and other plastics like PVC, ABS, stuff like that. And the reason that I like using sheet metal features for things like this is because it allows for easy DXF and exporting to DXF and DWG if you were sending your flat patterns to a CNC or a router table. So let's hop over here into SolidWorks and let's look at that. Okay, so got a piece of plywood here, and it has a mod or a like a tenon or a slot cut in this. If you had another piece of plywood that was going to butt up against it, and you can see that this is done with convert to sheet metal. So I could have done this in a solid body, right? And I'll show you that I have another part that is not done in sheet metal. And let's open that one up as well. And you can see that this one looks exactly the same, but it is not done in sheet metal, right? So what I meant by allows for easy exporting is if I were to right click this face here, and this, remember, this is the one that's not sheet metal featured. Right click and come down to export DXF. What it's going to do is you'll see that it's asking me to choose faces. So I can choose both of these faces, and it should, and you can see that the preview that it gives me is both faces, and that would be what I would see in DXF wise to my CNC router, right? But it's very common. I've seen it a lot where someone's in a hurry and they go to export and they forget to click both faces or something. So the cool thing about doing it with a sheet metal feature is now when I click and I right click and I export to DXF, it gives me an extra option up here. It recognizes that this is a sheet metal feature. So when I click sheet metal, it automatically comes in that way. And now I also have I can use this flat pattern. I have a flat pattern configuration that I can put on my print. That way I can show via print, I can show the operators of my router table exactly where that slot needs to be. That way they can program it on the router table to only cut so deep on that slot. Hit cancel there. Okay, and cancel one more time. So the last thing I want to talk about in my think outside the fold section here is there are also some unique cases where sheet metal features can be used in things that aren't actual flat sheet material. For instance, any kind of pipe or rod that uses bend or that gets bent, you can use sheet metal features to, and really the big benefit of using sheet metal features for this particular thing is it allows you to give a flattened part. That way you can give your fabrication team an accurate pre-bent length. So it allows you to flatten that out and measure that flat part. That way your team knows, okay, this grab handle that has 2 bends in it needs to be, 54 inches, 54.5 inches when it is flat before it's bent. So I do have some examples of that as well, and we will, let's see, simple grab handle. There we go. Okay, so this particular thing, it was converted into a sheet metal part, but in all reality, you make it with non-sheet metal features, right? So if I roll this up, you can see that we created a base flange, almost like a thin feature part, and gave it a thickness of whatever our pipe was. In this case, it was 1-inch pipe, so it's 1.05 OD. And then we fill it to give it the round shape, and then we cut extrude to get, because it's pipe, it's not rod. But now what this allows us to do, because we created it as a sheet metal feature, like I said, it allows me to hit this flatten button, and it's, there we go. Hit this flatten button, and you can see that it now, and of course, you have to be strategic about the way you do this, right? You'll notice that when I unsuppressed when I made my flat pattern configuration active, it did suppress a few of the features. And this is just one of those things that we've learned over the years, that because the only reason we are using this is for print purposes, these features aren't needed, right? That's just going to add clutter to your print. So we suppress them, that because from a 2D view, a round pipe just looks like a long rectangle, right? But now what we can do is we can see that this grab handle, to make that grab handle, we needed a length of pipe of 54.75, 54 and 3/4 of an inch. And so that's a cool, a unique way to use sheet metal features that is a bit uncommon and but has some really cool benefits. I do want to show one more here, and I actually have a print of this one. So this is a little more complex grab handle. And this one is actually solid, so you can see that it was just made with a sweep. We did a profile, and then we did a 3D sketch, and we swept it across that profile or that path. But then we converted it to a sheet metal feature. So the same thing, when I come down here to and make this active, you can see that it is now square, and we can measure an actual length. We know that this particular grab handle needs to be 26.643 inches long to be able to get the final formed length that we want here. So I actually do want to show, I'm going to open the print for it right here. And I do want to show what it, oh man, I renamed this to make it easier to open, and forgot that I didn't rename my print. So what we'll do instead is don't save. That was me trying to get organized before this presentation. So we'll just come up here. We'll use this one instead, and we'll just make a new drawing. We'll do it this way. All right, so now I can take, so just like, because this is technically a sheet metal feature, I have a flat pattern up here. You know, I have a flat pattern view that I can bring in. And I now have my bin notes functionality that I had when I did other flat pattern drawings, right? And you know, now I can come in here and I can say, you know, start of bend is 57 point oh, it's because I'm in millimeters. I chose the wrong template. But yeah, so start of bend, and then I can throw another ordinate dimension in here to say end of bend. And then just like any other sheet metal part, I can now project this, and I can change it back to the default configuration. And you can see that I can now show it formed, where I could, you know, I could throw dimensions in here for some sanity check, so that once they bend it, they can make sure, you know, they can quality check themselves and make sure that they have the bends correct. Well, shoot, that seems like that is the end of my presentation. Any questions there? I know we're a little over here. I tend to get a little bit of long-winded there. Wouldn't that be the center of bend, not start to end? So that is something that you'll have to, if this is a technique that you want to use, you would have to make sure you had all of that dealt with, you know, figure all that out with your fabrication team. In our instance, you know, we use this technique where I work in my place of employment, and we have learned that the way that our fabricators bend our pipe, the start and end of that bend is what they want. There may be some cases where you would want the center of bend instead of the, oh no, I see what you're saying. Yes, that bend line was the center of bend. I should have turned on I should have unchecked that merge faces button that I showed you earlier, because then I could have actually showed start of bend, end of bend. I just sorry about that. Yeah. So yeah, but like I said, our particular fabrication group likes to see a start of bend, end of bend dimension instead of a center dimension, which is why I instinctively kind of showed that. let's see. Another question here. This one's direct to me. Is it necessary or mandatory to flatten the part before importing to DXF? In if it is a sheet metal part, and let's actually just try it. Let's come up here to my number 2. Where'd you go? There you are. Okay. So I think if I'm understanding the question correct, you're asking, do I have to flatten it before I export? And I think the answer is, if it is done correctly and it is a sheet metal part, I should be able to export to DXF. And yes, just like I thought, because it is a sheet metal part and it has the sheet metal features, I can click sheet metal, click my green check mark, and it should, yes, give me a DXF that is the entire flattened part. So the answer is no, it is not necessary to do it that way.
Awesome.
Any
Well,
more
thanks
questions?
I haven't
Sorry, I
received
interrupted you, Steph. My bad.
No problem. I haven't seen any more questions coming into the chat. I just want to say that I really found super interesting the way that you guys use the sheet metal feature for fin functionality for tubes.
Yeah.
Certainly been in the situation in which I have to get that dimension, and I always end up doing it by center line, but then
Yeah.
I can't provide. I mean, it's more of a detail that I'm adding into the drawing more than and something that I have to like calculate and do kind of like a little bit more convoluted instead of just like putting it into the drawing. So that's really neat. That blew my mind. So great.
Good. I'm glad. Yeah, well, I just want to say thank you. I think that's the end. Yep, that's it. Thanks to everybody for joining. Thanks for all the good questions. Thanks, Steph, for setting this up.
Yeah, no, thank you. And give me 1 second. I have just like a few thank yous to share.
Sounds good.
So
I can stop sharing my screen here so we can see a better view.
Yeah, I think we're seeing over here. So yeah, so thank you so much, James. That was extremely interesting. So just as always, this is just a little blurb that I always put out there when after our presentations, that we have like the SOLIDWORKS User Group has a whole bunch of activity going up, and the SOLIDWORKS User Group network. So you can always, if you want to get involved with the SOLIDWORKS User Group in New York City, you can shoot me an email or join through our different platforms. We're in LinkedIn, Facebook. We have a Twitter account, which I need to manage better. But also LinkedIn has the SOLIDWORKS User Group community that it's like a global community in which they're getting everyone engaged. And then if you're interested in want to present, you can always shoot me an email. I'm always happy to host. And then thanks, James. I always give a little certificate for like a token of appreciation for giving some of your time into this activity. And yeah, I really appreciate it. So I'll be sending that over to you. But
sounds good. Thank you so much.
Yeah, thank you so much. This was super interesting, and I hope you all enjoyed, and I certainly did for sure. And I really appreciate it. Thank you, James. And
Yep,
thanks
thank y'all.
everyone for joining. Bye.
Bye.